Hello, everyone. I'm Andy Lin, Vice President of Strategy and Innovation here at Mark III. Thank you all for joining our Watch This Code session today. Looking out in the audience, I see many longtime friends and attendees of our webinar and events, but also some new names as well. Thank you all for coming, and we hope you find today's session practical and useful. For those of you who have not attended in the past, Watch This Code is a series of webinars within our webinar series all around DevOps and automation, focused specifically on empowering you to deliver modern services to your end users through the idea of learning by doing. Today's session will revolve specifically around enabling self-service VMs and containers for users with Ansible and VMware VRealize. For those of you who attended the last session and focused more around Terraform, coming out of that session, there were a lot of requests to do something around the VRealize automation as the platform, hence today's session. But we're definitely open to requests for future webinars. But quite frankly, that's what we operate on. So if you want to see us work with a certain tool set, please let us know. We are designing sessions specifically around making this extremely useful for the people that attend this. For this session, sort of after setting the stage briefly, by just letting you know kind of what this environment looks like that Bryan will be operating on. Most of the session will be Bryan just building things live, building workflows in VRealize. So this is definitely all around just doing things and making it super useful for you guys. A couple housekeeping items before I turn over to Bryan. First, if you have questions, please use the Q&A button at the bottom of your screen, or feel free to also ask a question directly to myself or Yusra, or Holly or Leslie on our team, who are all listed as panelists for this webinar. We'll make sure we ask your question to Bryan live. I think you'll see as Bryan gets started, he'll be working on a lot of different things. So just to keep him in the zone, we'll definitely read out your question live to him. And then secondly, we will be having a follow-on webinar in a couple weeks that will focus on the future of VMware, specifically around the latest vSphere 7 update from VMware, with a real-time look at what a vSphere 7 environment might look like with VMs and containers side by side. This is something we're asked about a lot and ties directly into actually the session today. We'll also focus on some other topics like enhanced vMotion, DRS, fundamental foundational things that I think that you'll find a lot of use on. We've recently set up this environment actually in our demo lab. Most have obviously not moved to this, so we want to make sure that you have all the information you need to make really, really great decisions. Of course, we're always here to help. So stay tuned for that invite following today's session. With that, I'd like to introduce our speaker today, Bryan McClellan. Bryan is a senior DevOps and Infrastructure Engineer here at Mark III. He's a solutions architect, Kubernetes enthusiast, and one of our leads for anything around automation, DevOps, transformation. He came to Mark III a couple years ago, but had been an enterprise architect, a systems administrator for more than 10 years before that at a very large organization. So with that, I wanted to go ahead and turn it over to Bryan. Bryan?
Hey, can everyone hear me?
Okay.
Great. I switched to full screen on the slide deck, and I have no idea what we're looking at, but I assume you guys are looking at a full screen of the first slide on the slide deck. Now the second slide.
Yes.
Okay, perfect. Okay, so this process is, we're going to go through like Andy, great setup. Thank you for the introduction. This process is essentially, the solution is essentially a few different products chained together to deliver a zero-touch virtual machine, and also in this case, a Kubernetes cluster. We're going to be doing some Linux, we're going to be doing some Windows, there's a couple apps we'll install as well. These are just examples. Like Andy said, we've got a few different pipelines in the lab. So this one we wanted to showcase, so here we go. Yeah, over 15 years, this is about me. Infrastructure, I work a lot on Kubernetes nowadays, always doing automation. Resources used in this demo. We'll be using VRealize automation to front end the forms and do some of the heavy lifting for data input. Red Hat Ansible automation platform is going to be finishing off the platform configuration. There's some Kubernetes clusters we'll deploy in this demo as well. All of this is on vSphere. We've got 2 different vCenters. We don't have any cloud in this demo, but we do have those pipelines as well. There is cloud capability, of course, with VRealize automation. I mean, that's one of the benefits for the blueprints. They can provision machines a lot of places. We're also leveraging Geneve, which is kind of the new VXLAN for software-defined networking. If you guys are interested, that we're using NSXT data center and other covers in this demo. So about the Ansible automation, I'm a huge fan of Ansible automation. I probably started using it about 1.5 years ago or so. I find it makes doing really difficult things easy. It's a multi-platform out of the box, so it'll do Windows, Linux, both pretty easily. No real coding, so all of this is built in YAML syntax. It's a good job manager as well. It's got a tower is what we're using to leverage Ansible. So Ansible, for the most part, is the automation engine. Tower is a web front end for controlling a lot of those jobs and job templates, and we'll be showcasing that as well. Yeah, that's all I got to say about that. VRealize automation. There's a couple things I like about it. One, it does forms really well. It has a custom forms built into the blueprints. And we use those. It's basically built off catalog items and approvals. So really, it can front end all of your items that you put out for self-service. You can tie them to business organizations, so it's doing full org structure with RBAC access, and it can just hand write off to VRealize Orchestrator. So we're going to showcase that as well. The anatomy of the self-service resources. So, usually the request forms, the previous demo that I did had ServiceNow front-ending it. This one doesn't have a ticketing system in itself, but VRealize has an automation, has ITSM plugin that plugs into ServiceNow. We're not going to showcase in that demo, but it is just a plugin that you add to the ServiceNow side, and it exposes your catalog items. So for the most part in the demo, accessing the catalog items and the approvals is the same. We're just not going to be requesting through ServiceNow or any type of ticketing system. So VRealize automation is essentially handling that piece of the top block. Workflow servers, we've got a couple of them in this demo. It's VRealize Orchestrator is going to be doing some workflow. Ansible automation is going to be doing some workflow. I'll explain why I've chosen to go that route during the demo. Bottom block is the hybrid infrastructure. The ultimate goal here is to get some infrastructure as a service, zero-touch delivery for virtual machines or Kubernetes clusters or namespaces or what have you, and then give them to the customer and have a fully auditable trail, right, of the request, who approved it if approval is required, and then build the machine in the designated infrastructure based on selections in the form. So you could build it in one vCenter, another vCenter, Amazon, Azure, what have you. So that's the goal here. Let's see. This is the VM pipeline process. The catalog item is requested from VRA. Approval process is applied in VRA if required. The reservation policy is determined. Now, the reservation policy in VRA is essentially determining where this infrastructure component is going to be placed. So via reservation policies, you can determine the placement of the requested resource, and that's how you would handle your hybrid infrastructure. You would simply just create reservation policies for a cloud or a resource in a cloud that you provision to, and the same is on-prem. So VRealize automation builds from templates. So automation actually is doing the provisioning of the virtual machine in this demo. It does a really good job. The blueprints are really easy. If you're just looking to deploy templates in with an approval process and get them in front of app owners or something, this is pretty simple, and we'll show you that. The second part is when it hands off to VRO. So we'll go through that. So VRealize Automation is going to build the machine from a template designated in the place where the reservation policy determines. And then once it's done, it hands off all the properties collected, if defined, to VRealize Orchestrator. VRealize Orchestrator will continue to build this virtual machine, perform different actions. What we're doing here is we're doing a couple hardware things, and then we're going to just simply pass platform components off to Ansible. So the Ansible host is created inside of Ansible Tower, and then there's an onboard workflow that's executed. So we're going to go through all of that. Machine build workflows, why they're important, right? You know, well, if you want a standard build and you want it auditable, then really building an automated machine build workflow is the only way you can get to that without having a post-process audit, at least coming in behind and doing that type of audit, and then checking for drift as well. So I find the best way to get the same machine every time in the same configuration is to automate it. A lot of this is built on software repos. Again, we're trying to produce the same machine build every single time, and we can integrate into CMDB. So machine build workflows, as opposed to simply going to your infrastructure and deploying by hand, right? We can start to tie it into CMDBs, ticketing systems, and so on and so forth. So, all right, I got a couple process highlights here. I'm gonna exit this full screen, and hopefully I'm showing the screen. Okay. Does everybody see VRealize Automation? Can somebody chime in? My
Yes,
screen's flipped on me, so I'm really trying to make sure we're good. Okay.
we do.
All right, so let's see if we can get this out of the way. Okay, so this is VRealize Automation. We have a few different components, of course. VRealize Automation is going to be handling our catalog items. It's where our blueprints are going to be. Orchestrator is going to be handling handoff workflows. We got a couple of vCenters here, and then Ansible is going to be handling post-process deployment. So we'll get right into requesting a couple things. So this is a PKSK, it's cluster. This is, in this case, this is pivotal Kubernetes, or TKGI as they're saying now. So we will we'll request a small cluster here. I believe I've got this up, so we can go PKS clusters, make sure we get a cluster. We got a few clusters, so I just want to make sure I'm not conflicting with a name here. We'll call it the 2001 demo. It's exactly 15 names. Let's go. Okay, so here's a request to request a Kubernetes cluster. We'll get into the workflows in a second, but I want to go ahead and request a couple of machines because some of these guys take a long time. So we're going to request a 2000. This is a 2019 server. There's other ways through the administration components here. We'll get into this in just a second. But for the most part, this form is built out with information driven from components that we're using in here. So we're going to show you some of that information in just a second. So let's just go 1, 2, 400. So these locations are built off reservation policies that I've defined inside of VRealize Automation. So what these locations are, they're VRealize Automation reservation policies that are defined in infrastructure. Oh, this occurs sometimes. So reservation policies are defined, and then they are applied to reservations. And these are simply clusters that you bring in through IaaS components, right? So you add an endpoint, you bring in clusters, you assign them to reservation policies, you then begin to expose that information through here. So now that you see the catalog items, we'll get into the design. So what we're dealing with here for the most part are blueprints. And blueprints, are, I guess, exactly what you would think. If you open it up, it kind of looks like a blueprint. But in this case, we're editing one of the Windows Server blueprints. If you see, what we do is we simply say that, you know, we want to use a virtual machine, and in this blueprint, you could actually deploy all kinds of things. So you could stack up a few machines and build a real large environment. In this case, we're going to a single machine, which is the simplest deployment methodology here. So we drop a vCenter machine on here, and then we go here and we start to fill out some of the data. So we're displaying location information. What's really important here is this, right? This is a clone action from a template. It's a clone workflow. This is the template, and this is the customization specification that we're going to use. So this is very much like what you would fill out if you're deploying from a template in vSphere, except for this clone workflow. You wouldn't know it about it, but it's just part of that workflow. So, you know, along with the resources in the template, we can also apply t-shirt sizes to this. Now, this is built into VRA based on properties. Profiles. Yeah, so we're using a size profile on the template. So I find everything in VRA is built around properties. So in this case, we're using the size profile, but in the size profile, we've got sets of properties. In this case, we got a value set: small, micro, medium, and large. Now these are defined outside. We'll jump out for a second. See if I can find my property definitions, custom profiles. So if we get to component profiles, this is well documented on the internet. So if you you come here and you define the sizes for each one. So in this case, it's a micro. It's going to go 1 CPU to 2 gig of RAM and then 40 gig of storage. I want to be sure that I point out here that this amount of storage is the total amount that they can request in the reservation. So it's not going to change the size of the disk on the template. It is simply just allowing them. These two components, however, do affect the resources provision onto the machine. So this one is a little bit misleading. Just keep that in mind if you're setting that up. You can change this number. It will not change the size of the disk. Okay. So, so as we go through this, you see component profile, size is the profile. We set up these definitions. We defined the resources. We'll jump back. There's a lot of stuff here, guys. And if you're, you know, if you don't catch it all on this demo, feel free to reach out. I'll go out over it with you anytime. So we're going to get back to the component profile. So general information on the blueprint, the build information. These are machine resources. You know, it's looking at the template for this information. Again, this is a 40 gig disk. So if we wanted to, on the template, so if we wanted to change this, we have to make adjustments, and I'll show you that in a minute. Network is DHCP. Here's where we get into the properties. So now, here's kind of where I think the rubber meets the road. VRealize Automation is really good about deploying templates, and it can do that pretty well, and it can collect properties. But it itself does not take action on the machine or any action outside of deploying the infrastructure component. So we're going to leverage Orchestrator for that. What we're going to do is we're going to use an event subscription. So any custom properties that you collect on the machine, and these are available, I've got a few here, like reservation policy ID, patch group, support group. This new size gig, which is actually a technique I use to change the C drive by collecting a new size for the C drive, and you know, host name. This one is the important part. This is where we're going to start passing all the properties that we collect in the form to Orchestrator so it can perform post-provision actions. So any property that you want to pass to this event subscription, which is this guy, and I'll show you the details on that in just a second, will need to be defined here. Now I've started doing a few things. You can actually have a prefix on your property that you want to pass through. You can just do a dot and a wildcard. So this works. I've got a couple check boxes. There's a few properties. But if you stick with one, I've got a couple in here that go MOB dot, MOB dot. And if you just named all your properties MOB dot and you did MOB dot star, it would catch them. So that's a kind of a got you, and one thing I'd like to point out. All right, so back at the property. So that's pretty much the blueprint, right? We've got a template that we tell it here in the build information. Here's the template. Here's a custom spec. We're going to clone it. Here's all our properties that we want to collect on the form. The properties are exposed in the form. I just pressed the edit form button. It's the edit custom form. So later in the VRealize 7, they released the custom form. So it allows you to build a nice little form here out of the properties that you collect, plus the default. So if you see, here's like MOB support group. That property that I defined on the blueprint is now exposed in the custom form on the blueprint element. So now to use it, all they have to do is simply drag and drop it here. Give it a name. Let me give it a name or a label, right? The name will stay because the property right here is the property that we're going to be using. So what's so great about this, I mean, is that you can move from free text fields to drop downs and so on and so forth. This one here we'll delete. We'll go to this patch group. If you look at this patch group one, it's kind of unique. So what I've done here is I've created an action inside of VRealize Orchestrator that queries AD for any groups named that starts with this prefix. So I can say, give me all the AD groups that start with this prefix, patch underscore. So this will reach out to AD, compile a list, and then put that list in this dropdown. So what this allows me to do is present a list of names of AD groups that I want to join the computer to after it joins the domain. And in this case, I'm simply leveraging this patch group. Perhaps it's a patch cycle. In my lab, it doesn't really do anything. But if it was a patch group with some type of patching software, leveraging the AD group for its patch cycle, then this would do that. Now, once you have tap into Active Directory group, right, if you look at this, we could tap into all kinds of things. So Active Directory groups and putting your computers in groups, you know, it's been used for years to do, you know, provide some type of application tie-in, right? The application's using Active Directory, it finds a computer in a group and so on. So whether that's patching or reboots or whatever you have going on, we can put a computer in an AD group after it's finished. This one is that custom property for the C drive. I'm not going to get into this too much. I think it's a little more complicated than it should be to increase the drive of the C drive, but this is well documented. This new size gigabyte, this is a documented process that's out on the internet. This is me simply providing constant values of 40, 60, 80, 100 into a drop-down box. So whenever I choose, the component is chosen, if you go back to the custom form and the catalog, you see now the drop-down is full with these properties that I filled out in the constant values. So now if I select 100, or we'll go, I might have a limit here based on the size. So we'll go up real big. And we'll deploy it into some patch group. We won't do the updates. So I'm going to jump around and check on some of these workflows for a moment. Okay, so trying to look at what component we just request, the PKS cluster. Now we've got a Windows machine going. Okay, now this is the deployment section, and I don't want to. We've got a lot to cover, so I'm almost 30 minutes in, and I don't want to spend too much on VRA. But this is the deployment section. This will house all the deployments that you choose from the catalog if it's a blueprint item. So anything chosen will show up here. You can see our PKS cluster. It says it's successful, but I know that in the background it's still working. We'll look here. Yeah, you'll see the build demo that we have here. Our PKS cluster is still in progress, so we'll give it some time. Go back to deployments. This is the Windows server we just selected. Properties. So this is our VRA large 01. So now we'll go into what happens after the machine is deployed. So as the machine is deploying, you'll see here's our machine already building out into the selected vCenter. It's going to do exactly what you do if you deployed from template. It's going to choose the custom spec. It's going to customize the OS and that kind of thing. Once that process is completed, we'll go back into VRA so I can try to make the transition here. Once the process is completed, VRA has these subscriptions. So what it does, basically under the covers, is if we set up a subscription, we can tell it under these conditions. Okay, so if it's a virtual machine that was deployed, the life cycle state is activated after the machine, after a virtual, so in kind of English, it's after a machine is activated, right? Then perform this workflow, which is a custom workflow we have here, which is mob custom.event broker machine activated. So if we come over here, here's our workflow. We're going to look at it for a second so we can take it apart. Now, what happens when VRA does this handoff is it hands a payload packet full of properties to VRealize Orchestrator. Now, these are properties that you've told it to pass through. Back here on the, I want to make sure that I get this up. This is very important. Here. So any properties defined here will be passed through to the workflow in a big payload for properties. That is rendered here in the script. So this is part Frankenstein script was something that I found and a lot of custom script writing. So for the most part, VRealize Orchestrator, number one, it's almost all of the scripting, if you want to do it in the tool, is JScript, JavaScript. So I'm not a writer in JavaScript. I write in a bunch of languages, but it's fairly simple for the most part. I try to not do anything super technical in the JScript. This stuff is simply just grabbing properties from an array. So if you look here, I'm just logging a little bit of information. I'm grabbing some VRA VM properties. So now this is the part I want to highlight, right? I know the property names because I've passed them through and defined them. As I go through the properties here, I define the var, right, for all of its properties. Then I start to identify the instances in the array of properties, in this case, the mob.patch_group, and I load it into a patch group variable. And I do this with the new gig size. I do this throughout on all of the properties. I start passing them into variables. Then I evaluate them. And this is where the power of Orchestrator really comes through. It now has all the properties that we've defined for the virtual machine in the blueprint and the custom form. We've exposed them so that users can make their choices. And then we pass their choices on through the machine activated subscription to VRealize Orchestrator. It unpacks the properties, and then I start defining them into variables. Now, what I'll do from there is I start doing some, most of this is really debugging, but what I'm doing here is I have this install software array, and I start throwing things into it. So update all becomes an instance in the array. It's really a list. So install IIS, if install IIS property is true, right? And that's a selection on the box back here on the custom property. Catalog request. Here, these checkboxes. So they're yes or no, true or false here. It evaluates it if it is, and then it pushes install IIS into the array. This is a technique that I use all the time. I take a list, an array, and I start to fill it full of things that I want to execute. Right? If I want to install SQL, I I put it in the array. If I want to install IIS, I put it in the array. If I want to update all of the software, you get the idea. I put it in the array. This is me debugging some of the important properties that come out, and then this is me just looping through them so I can see them all to make sure I'm not missing anything. This is the first script. So VRealize Orchestrator on this thing just got it. I've unpacked the properties, I've loaded them into variables, right? All of these variables are also defined here, right? I think Orchestrator can get a little intimidating on its properties, but it's from a visual perspective, it's really good. From there, right, part of that input, part of the properties that I got is the name of the VM that I selected. So if you look here, string name VM is the input. Now what I'm going to do with this one is I got to get the virtual machine. So while VRA knows a lot about the virtual machine, it doesn't hand off an object, right? And Orchestrator is going to perform on this type of object. VC, I can't highlight it, but it's right here on this property, VC virtual machine. So we need to get that so we can give it to Orchestrator so Orchestrator can start to perform. So this first step is unpack the properties, get the virtual machine from vCenter. We do this via other properties, you know, what vCenter is it in, where is it at, right? Now I need to hand it to Tower. The Tower ID, so I get the VM data, right, in the VM output. And then I need to format the Tower ID for Tower, because Tower itself uses a unique way of identifying vCenter virtual machines. If you look here, here's our large VM that we just deployed. It's already made it to Ansible, you see. This is VRA large 01. This is the BIOS UUID from the VM. So this is how Tower identifies the machine as unique, because if you didn't know, in vCenter you can have the same name for a virtual machine as long as it's in a different folder. You could name VAR large, and I could have one in each one of these these folders on this side probably, but you get the idea. You can have a machine with the same name in vCenter. So how Tower deals with it is by adding the UUID. I need to get that information, and I can easily get it to call a Tower job by looking at the UUID of the machine. You see, I got the VM, I've got the VM object. I just take the VM's name in lowercase, I trim it, I add an underscore and the BIOS ID, and that gives me this name, right? So then I call Ansible inventory. So really all I'm doing in this case is just telling Tower to import this machine. And I give it its IP address, so it knows where to connect to if it's having trouble with name resolution. This is its key to get there. So I have all that information from inside the VM output. So if you look here, this is also that VM object that we were just talking about, and the guest IP address property inside of that VM object. So here I just debug the output so I can see it. Then we move on, right? Now we're going to run the Ansible install. So these are the workflow that we're running here is run SSH command. So I guess a good question is, why am I handing it off to Ansible at all? And the answer to that is that VRealize Orchestrator is really good at managing infrastructure, I find. It is not really good at managing the platform, right? So I want to get this into a platform management system, a configuration management system. Orchestrator is not that. So we want to get it into the configuration management system. And in this case, we're using Ansible. So really what I'm doing here is I've got an Ansible server that has Tower installed on it. And there's a set of commands on the Tower server. There's a command line utility, Tower CLI. So Tower CLI has a config file where you fill out the information and you can vault it. So when you run Tower CLI commands as that user, it will use the user's config. This saves a lot of the information where I can format the Tower ID here, and I can simply call the command Tower CLI create host, and I don't have to give it a username or password as long as I'm using the user with a Tower CLI config. Then it knows that information, and it will, like you see, create the account. Now, why we're doing that is because the next step, this one, we were running Ansible installs. We're actually going to kick off an Ansible job here. So this is Ansible Tower. This is what I call the win.run production config onboard. It's a long name, but really what it's doing is it's going to check, and we'll get into the code in just a second, but it's going to, based on the tags in this array, which is this install software list, right? If we go back here to properties, you see I'm loading it up in here, right? Full of information that's been checked. So the array becomes full of things, right? And then I pass that array to the SSH command for Tower CLI, right? Then it will go in here and run this job, which again this is the onboarding. And we'll look through the log real quick and the things we selected here. So this one will do configure Linux and Windows. What I'm doing is installing an agent for login site here. That installs a login site. It was installed. You can see because it's changed true. It installed IIS. We made that selection with sub features and management tools. So you'll see it tells you what it installed here. You can get a lot more detailed inside the debug log here. But that's Ansible Tower doing our post-provision tasks. Now you can do that some stuff with Orchestrator where you run commands inside the operating system, but you never know if they finished. You're kind of blind to the output. So that's why I like to run the job in Ansible to get the outcome. If you look, it's green and Tower tells me that the last job was successful. I know it's onboarded. I know it's ready to go, right? I don't have to even look at the logs at this point, except for to verify exactly what was done. I can know what was selected was done because if it wasn't, it would have failed. And then I would be notified, and then I can go mine the machine and maybe have a redeployment or what have you. So, okay. So then we run the Ansible installs. At that point, it's handed it off to Ansible. Ansible's inside the platform. It's making changes to install an IIS, whatever. It's going to upgrade a VM tools. There's a selection I have back here to install all of the latest updates, which I usually don't. It takes a long time, but this will update the template as soon as it comes out of the pipeline. It'll have all the most recent critical and security updates. And this is also an Ansible job. Okay, right. We're going to finish this Orchestrator workflow. I'm determined. Okay, so in this case, you'll see that from here, I do a couple of other options where I switch to see if the machine has a larger drive than 40 gig, which is the default template size. Sorry about the dogs. If it is, then I will move to the extend the C drive. So you'll see there's a case in point on this switch. If the new size is greater than 40 gig, then it returns true. And then we move to the extend C drive workflow. The extend C drive workflow is all based on that new size gig, which I showed you at the very beginning in the properties. So this workflow will simply extend the disk drive. I think that if you look here, right, we chose 160 gig. You'll see 160 gig VM came out the pipeline with the right. This one is the maintenance group. So this is where that Active Directory group piece comes in. So if a maintenance group is defined, then it will move on to this workflow, which is to add the computer to the group. It's a custom workflow that I built here called Add Computer to Group. All right, now we'll get into the Ansible part. One second. So in this In this demo, we've got a couple of options. 1 second, please. All right, are we still there?
We are.
Okay. So now we're going to get into the playbook. If you see here, really on the tower side, let me bring tower back into the view. So Orchestrator comes through. I'm going to leave this workflow. This isn't found. Oh, yeah. Yeah, I've been troubleshooting my AD group thing this morning. I had some problems with it. So that will show you that everything completed except for our group. You'll see back here. Oh, failed workflow. So this is a good example of the debug workflow. Yeah, you'll see. You got to really dig into the logs. What happened is I'm looping through an array, and it's got a small problem with the group that I didn't even know was happening until before the demo. So we'll leave that on the table. As far as the workflow, everything else was completed. We've got extended C drive. We're gonna go. Wanted to show this. For my Ansible piece, where we are we're handing off the work for the platform pieces to Ansible. I want to kind of get into how that's built. So if you look here, the playbook in Ansible is really just kicked off of a job and a job template. So we'll take a look at this guy real quick. It's our onboard workflow. This is the WinRun production config. Again, this is the workflow that's kicked off. Everything's built off variables. You'll see there's a bunch of variables in here. The default job tag, I like to keep all the templates updated, so I leave the tag on here. But if you see, this is the playbook I'm using to kind of kick this thing off. In the playbook is really just a YAML file. So if you see here, I'm not going to get too deep into this, but I'm going to show you the technique that I use, and this code will be available after the call. So if you look, we've got, the play is defined. There's a couple of variables that I throw up front here because one of the options is to disable SSL v2. Because I want this multi-platform, I'm using a block. Now this is YAML syntax for Ansible, but I'm calling this a Linux block. And what I just say is in this block, when the Ansible OS family is equal to Red Hat, I perform these actions if they're tagged. So in the tag definition, you see I've got this one tagged as always. So the log inside agent will always install no matter what's in that installed software list that I was defining in Orchestrator. If you look here, this one, if HTTPD is in the install software, it will install it. So here is why I wanted to show you this, is because this is exactly where we're applying that install software list to be able to perform the actions that we want to complete on the machine post-provision. So in this case, we've got the log inside agent always installed. If HTTPD is in the list and it's a Red Hat box, then it will install that. On the Windows side, it's very similar, but there's a lot more things, as you can imagine. So when the Ansible OS family is Windows, and Ansible knows this because it talks to the machine, and will gather the operating system information. So if the Ansible OS family is Windows, then you'll go in and start to look at these tasks. Now these are each one of these are tasks defined inside of Ansible. by the tag. So if you look here, this one says disable SSL, and the task is disable SSL v2. So if the tag is met, it will run this YAML file. And then if we go look here, you can see here's the task folder, and then our YAML file for disable SSL is right here. And we just take those keys defined. This is why I like Ansible so much. Really, I'm just running a WhenRegEdit module. I loop through the keys and I tell it what to do, which is set a dword to 0 in the registry. Very simple. Now, a lot of this is easy in PowerShell as well. There's some benefits to writing it like this, because you could probably use a different 3 or 4 different ways to modify the registry in Windows with PowerShell. And in this case, you just use the module. So, all right. Okay. So does I guess I can open for questions at this time about the tasks. I really don't have much to go over as far as the tasks, except for how this is defined. I kind of want to show the Kubernetes cluster stuff. I'm going to move on to that, if that's okay. Okay, so here's our Kubernetes cluster that we created. It's already deployed, as you can see. We're going to see if we can deploy an app to it. Credentials. So you could, if you were serious enough, do deployments into Kubernetes from the self-service portal as well. I mean, if somebody could select the app and you had a YAML file that defined the deployment, you could deploy the Kubernetes cluster and deploy the deployment via the YAML file as well. In this case, we're just preparing it for the developers so that they can do whatever they wish with it. So what I did here was we found our cluster. We've got, in this case, the pks command will give us the context, so then we can run kubectl commands on the cluster. So we'll just get the nodes, see what it looks like. So all our nodes are up, they're ready, right? Our Kubernetes commands are working fine. We're going to kubectl. Oh, before we do this, let's get pods to make sure. Let's see any pods. Okay. So now we're going to see if we can kubectl apply. F. And in this case, I think we're going to use this guy. Right. So what I did, you see, here's the YAML file defining the Yelp app. It's out there on the internet. Everybody uses it for demo. It's got, it's a, you know, your basic cloud native app. It's got, you know, deployments defined. It's got the load balancer defined. Since we're using PKS with NSX, it's going to create the load balancer. Your middle tier apps, database backend, Redis server cache. So a bunch of things, right, that it's running. And it's your I guess you could say a good example of a cloud native app. Now we see we get the pods here. We've got our pods running. You see there's 3 pods here. Database, three pods per tier. And if we go down to deployments, you'll see replicas 3. So it's matching that. You know, you can, of course, change the deployment here to 4. Right, replicas will reapply to get a new deployment going. We'll get our pods. We'll see this guy is creating and running up, right? All right, and then we'll kubectl get service. Now, because we're using Kubernetes, or PKS, I'm sorry, with the load balancer on NSXT on the back end, all of the networking components are automated. So it has a pool of IP addresses. It will configure the load balancer and apply the IP address to the load balancer for you, using the external IP address for your load balancer service here. So that's what this information is here. And we can see if the app works by going to this IP address and ta-da, right? We've got Kubernetes running. We've got our application deployed. We just voted for Chipotle. Yeah, Chipotle. And that's pretty much it. Now, I'm not going to get too deep into Kubernetes, but that handles deployment of Kubernetes app, right? We've got the code, which we'll give you at the end of the demo. We've got our large machine here that's fully deployed. All right. There's a couple other things. You know, once the machine is in tower, really you have. I think I've got a filter here. You have day two operations that you can perform on the machine as well. So let's say if we wanted to install SQL or you know, a few other things that we can run, we simply launch the job and limit it to the machine that we have in here deployed. So we'll take that action on that machine. So now that we have it at Ansible, we have it fully controlled. We've got the deployment listed inside of VRealize automation. So we've got the deployment and all the properties. We can take actions here to destroy it, right? We're going to end its life cycle, right? And then we can have post-destroy actions that do cleanup as well. So really, you know, again, VRealize automation to handle the forms, Orchestrator to kind of do some heavy lifting on the virtual machine side, more for collecting data. I'll need to see what's going on with this guy. We got our VM deployed. We have Ansible running running jobs and managing the platform, and we've got our Kubernetes cluster. Okay, any questions? I'll open the last 5 minutes. Any questions, or if you want to see a task built, we can look at that too. If anybody has any specifics on questions on why I designed it a certain way, I'd love to hear those.
Yeah, Bryan, I've got a question for you. When would somebody think about using maybe the VRealize approach versus maybe the approach from last session, which was more focused around Ansible and Terraform?
Sure. Yeah, so I would say that if from my perspective, it really comes down to separation of duties. If you can get a ServiceNow administrator, or you are a ServiceNow administrator, and you can build your catalogs and items and approval workflows inside of ServiceNow, do that. If you have a VRA admin also who's, if you're doing heavy that as well, do that too. So I would say if you have if you already have a strategy with VRA and you're building catalog items out with your business units and groups in VRA, exposing that through ServiceNow and leveraging those approvals is perfectly fine. If you have a well-established catalog item and approval process in ServiceNow and you don't have that in VRA, then I would probably, I would decide which one was a better fit. I can tell you that VRA adds a lot of complexity. This is 7.6, right? 8 is out now, and there's a learning curve to it. None of these VRealize automation and the Orchestrator products, I wouldn't consider them easy to use. They require an FTE, I would say. So if you're trying to, at least, so if you're trying to, I guess the answer to the question would be whatever strategy you already have, and if you don't have one, spend a lot of thought on where would be the best place to build catalog items and approval processes. If you want them in ServiceNow, put you know, front end them and build them in ServiceNow. If you want them in VRA, then do that.
Awesome. And here's another question. I'll just kind of paraphrase this. But if obviously you went through a lot today, this is sort of the end game. if you want to call it, as far as like, sort of building out a full workflow. As far as like from skill set perspective, I mean, if people are just kind of getting started, maybe they've been focused on, being sort of the best system admin in the world and are starting to get into scripting and coding at a high level. Do you have any advice generally for them?
Yeah, that's getting into scripting and coding. I would say, you focus on first focus on object-oriented programming language. PowerShell is one of those, so it's a good one. I like I would also look at both an object-oriented programming language and then a declarative automation engine. And whether that's Tower or Chef, there's a bunch out there. So I lean on Ansible. I like it and I use it. But I think that combining both is really important. And I would begin with automating background tasks. That's kind of where I cut my teeth, really, was in Active Directory automation. There are just so many objects and managing attributes, and auditing that information was kind of where I cut my teeth. And then move from there to self-service automation, because really the self-service part is where it becomes a little bit more complicated. When you're dealing with user data, user input data, you have to take a lot of things into consideration. You have to present the right kind of data, where you're going to get the data from, and that kind of thing. Whenever it comes to back-end routine task automation, you're not dealing with a lot of that most of the time. You want to, clean up a directory or update a template or something like that that doesn't require a lot of user input. So definitely look at both object-oriented scripting language and a declarative language like Ansible or something like that, and try to make sure that you hone your skills on those in the background processes, and then start to bring them out to the users, of course.
Awesome. Well, we're right up against the hour, so very much appreciate everyone attending today's webinar. We'll be sending out a recording after this for you to actually look at, as well as a link to Bryan's GitHub repo. We're always around in case you have any questions, but thank you all for joining. See you next time.